Hello, this is Mr. Stansbury. I'm going to take you through the notes on solving systems of two equations and two variables. At the end of this, you should be able to say, I can use graphing, substitution, and elimination to solve systems of linear equations in two variables, and I can formulate systems of linear equations in two variables to model real-world situations. Okay, a couple of things to talk about. A solution of a system of equations is a point or set of points that make both equations true. So, like if this is an equation of one line and here's an equation of the other line, then where those two lines meet is the solution. So here's another example. And then something else, another possibility is you could have this line here and then another line that is exactly that same line, and that actually makes infinite solutions. So that's if the two lines are exactly the same. Okay? Now, with that, let's take a look at an example here. It says, find the solution to the system of equations 3x plus y equals 5 and x minus 2y equals negative 3. Now, there are three different ways that you can go about solving this, or at least I'm going to show you three different ways. There's graphing, there's substitution, and there's elimination. Okay? So, with graphing, what we want to do is we want to, actually I'm put it down here in steps. So the first step here is to solve both of these equations for y. So we want y equals for both these equations. Okay, solve both equations for y. Okay, so let's do that. So let's see, we're going to subtract 3x from both sides on this one here. So we get y equals, and it's, to make this a little bit easier for the graphing piece, it's usually easiest to put the x first and then the constant after. So we get negative 3x plus 5. And then over here, let's see, let's subtract x from both sides. Negative 2y equals negative x, minus 3. And then we divide both sides by negative 2, every piece here. So we get y equals, let's see, that gives us 1/2 x, and then negative 3 over negative 2 is plus 1.5. Okay? Okay, so now the next thing we're going to do here is we are actually going to graph both of these lines here. Okay, so we're going to graph this first one here in red. So let's see, we're going to start at 5. And then from there, we're going to go down 3 over 1, right? So we'll go down 3 over 1. Maybe go down 3 more over 1 more. And then to graph that line, we need to make ourselves a nice straight line. And that's pretty close. And then let's see, we'll do this other one over here in purple. So we're going to start at 1.5 is our y-intercept. And then from there, we're going to go up 1 over 2, up 1 over 2, and then make another straight line. And that there is pretty close as well. And then our third step is to find the point where these two lines intersect. Okay? So that's going to be right here is where those points intersect. Okay? So, in looking at that, it looks like it's at 1. If I'm, that's the thing I really don't like about the graphing to find the solution, is you're just kind of eyeballing it. But that looks like the solution is going to be at 1, 2. That's my guess. That's pretty close to that. Okay, so that's one way. Another way is substitution, and substitution is just like what it sounds. You're going to take one thing and you're going to substitute it into the other. So steps for this is, the first thing we're going to do is we're going to solve either equation for either x or y. It doesn't matter which one you choose. Okay, so we can pick either one. I'm just going to go over here to this one and I'm going to add 2y to both sides, because if I do that, then x will be all by itself. So x equals 2y minus 3. Another easy way we could have done that is subtract 3x from both sides on this, and you get y equals negative 3x plus 5. Either one is fine. Okay. Now the second step here is we're going to, the one that we just solved here, we're going to plug that into the other equation. So what that means is we're going to take this 2y minus 3 and we're going to substitute that in. Wherever we see x, we know that's the same as 2y minus 3. So we're going to substitute that in right here for this x. Okay, so we're going to go 3 times. Now wherever we see an x, we're going to put 2y minus 3 in there. 2y minus 3. And then we still have plus y equals 5. And I should have put this. We're going to substitute into other expression and solve. Okay, so let's get rid of that period there. And solve. Okay, so let's see. We've got to distribute this 3 through to both of those. 3 times 2y is 6y. 3 times negative 3 is negative 9 plus y equals 5. So we're solving. There's only one variable to solve for. That's the whole purpose of substitution. So 6y and y is 7y minus 9 equals 5. Add 9 to both sides. And we get 7y equals 14. Divide both sides by 7. And we get y equals 2. Okay? And then our last step here is we're going to take whatever we get for our solution here and plug it back into either of the first two original equations or this solved equation here. I usually choose this one here because if we plug, now that we know that y equals 2, we're going to plug 2 back in for this y here and figure out what x is. Okay, so now we have x equals 2 times y is 2 minus 3. So we get x equals 4 minus 3. X is 1. So we get x is 1 and y is 2. So our solution is going to be 1, comma 2, which you'll notice matches this one here as well. Okay? And then the last one is elimination. Okay? So with elimination, the first thing we're going to do is we are going to multiply either one equation or both equations so that either of the two variables, when you add these two lines together, that either of the variables will drop out. Or another way to say that is that either of the variables are opposites of each other. Okay? Okay, I know that sounds kind of confusing, but basically what we want to do is we want to multiply one or the other of these equations here so that we get opposites. So for one of the variables. So like this is 3x. What I do is I look for the bigger of the two. So this is 3x, that's bigger than x. I could multiply this whole row here by negative 3. So then when I add these two together, the x's will drop out. Or what I'm going to do instead is, because to make it a little bit easier, is I'm going to multiply this row up here because we got negative 2y. Opposite of negative 2 is positive 2y. So if I multiply this whole row by 2 up here, it's going to give me 2 times 3x is 6x. 2 times, so I'm going to distribute this 2 to all 3 pieces. It's super important to not forget the last one because that's a common mistake. 2 times y is 2y, and then 2 times 5 is 10. Okay? Then what I'm going to do is I'm going to actually move this other equation right underneath the one that I just made, and I'm going to add them together. Okay? Okay, so I'm going to do this, move this over. We got x minus 2y equals negative 3. And as you can see, when we add these two lines together, that's going to turn into 0. So we have 6x plus x is 7x. 10 plus negative 3 is 7. And then, oops, and I forgot to do the same thing here. And add the two lines together and solve. And, oops, let's do that. Spell it out. And solve. Okay? So, divide both sides by 7 here, and we get x equals 1. Okay, so we know that our solution here, the x is going to equal 1. And then our last step here is to, just like what we did over here in the substitution, substitute the, plug the value back into an equation and solve. So we're going to do the same exact thing. Okay, so plug this 1 into either this one, or that one, whichever one you want. This one's kind of handy, so I'm just going to plug this 1 here in for that x. So I get 1 minus 2y equals negative 3. Subtract 1 from both sides. We get negative 2y equals negative 4. Divide both sides by negative 2. And we get y equals 2. So then that 2 goes there. Which again, if you'll notice, all of these here are matching each other. So that's 3 different ways to come up with the same answer. Okay, I'm just going to tell you for my class, when we go through and test, I'm just going to have you do whichever way works best for you. So if you can get really good at one of these, then you're in good shape. If you're gonna pick and you're not really sure, most people tend to lean towards elimination. Over time, the more you do this, the easier this becomes. And really, if you look at it, there's not as much math here in the elimination and then the graphing, I would highly suggest staying away from graphing because you have to eyeball if you draw your lines just a little bit crooked, you're going to end up with a wrong answer. So definitely choose between one of these two, and I would suggest elimination. Okay, we're going to do a one last quick word problem, and then we're all finished here. But before we do that, let's take a quick comedy break. All right. Okay, let's take a peek here. Oops, gotta get rid of that too. Okay, our last one here. Petey goes to the 5-legged antelope park and notices that there are both humans and 5-legged antelopes. He notices that there are 33 beings and that there are 117 legs. How many 5-legged antelopes are there at the park? Okay, so let's... what we want to do is we're going to do just like what we had before in the previous example is we're going to try to come up with 2 equations and have 2 variables in there. So let's do this. First thing that's I think super important, it makes this a lot easier, is we're going to set up our variables. So we have, let's do b equal the number of beings, right? Oh, actually, wait. Instead of beings, let's do... Sorry, we've got antelopes and humans. Let's do that. That makes more sense. A equals number of 5-legged antelope. Okay, and then H will be the number of humans. And I guess we're going to assume that those are all 2-legged to make this problem work out, right? Okay, so if we look at the first thing here, he says there's 33 beings. So we know that antelopes, 5-legged antelopes plus the number of humans has to equal 33. Okay? And then he also notices that there's 117 legs. Okay? So for every antelope, there's going to be 5 legs, right? So 5 times the number of antelope plus each human is assumed to have 2 legs. 2 times the number of humans is going to give us that's going to give us the total amount of legs, and we know that that's 117. Okay, this right here, just coming up with your 2 equations, is probably about 80% of the battle that you're going to be running into here. That's the tricky part. So really focus in again, like set yourself some. Try to figure out what you're trying to understand, what you're trying to find. So how many 5-legged antelopes are there? That's why I should have definitely started with A for antelopes. And then also we're going to figure out how many humans there are. So assign your variables and then use one sentence to come up with 33 beings. That's one idea. And then there's 117 legs. That's the other idea. Okay? Once we do that, now we go through and solve. And I'm going to use, for this one here, I'm going to use elimination. Okay, I find that this is over time. You will definitely become familiar with this, and this will probably be the easiest. Okay, so 5. I could multiply this whole thing by -5, or I could multiply this whole thing here by -2. And if I do that, then my h's will drop out, right? So -2, distribute that -2 to all 3 pieces, and we get -2a minus 2h equals -66. And then remember, we're going to move this equation right underneath it. 5a plus 2h equals 117. And then we're going to add these two together, right? When we add those two together, one of the variables is dropping out. That's why we call it elimination. We're eliminating one of the variables. Okay, negative 2a and 5a is 3a. Let's see. All right, got our calculator here. We've got 117 minus 66 gives us 51. Divide both sides by 3, and we get that a is going to equal, let's see, 51 divided by 3 gives us that there are 17 antelopes, and that's what they were asking for. How many five-legged antelopes are there? There are 17 of them. Okay? All right, that's all we have for the solving systems of two equations and two variables. If you have any further questions, please feel free to ask. Thanks.